Good evening, everyone. Thanks for staying around after that incredibly short 15-minute break. You've all had pizza now. Normally that makes people tired, when you go to a conference and they eat pizza at lunch and then you've got to wake them up. But hopefully we've not got that problem today. I'm going to talk to you about the hidden magic of decorators. What's that? I just got to hide that guy, right? Oh, it's on this screen as well. I'm mirroring. Good, thank you. The details matter. The hidden magic of decorators. I'll do the intro thing first. My name is Michael Bromley. I only have one t-shirt, as you can see. I can. If you're not even sure that it's me, then just check it out. I'm building a open source e-commerce platform called Venture. It's built on top of NestJS. I've been building it for 6 years, so I've been using NestJS for 6 years. Yeah, long time. I'm on X. I'm on LinkedIn. If for some reason you want to know about the things I post on there, you can follow it. That's enough of that. Decorators. If you're using NestJS, you're using decorators a lot. And it's an interesting topic because it's one of those things where, I think a lot of people don't really exactly know what's going on with decorators. I know I didn't. You just see them in the docs. You write the little @ sign, you do the decorator, it works, and then that's all you really care about it. But I got kind of interested in it because in the course of building my own framework on top of Nest, I ended up making my own decorators, and they're very useful. So I thought it's something that probably a lot of people could make use of that if they understand it better. So hopefully I can enlighten you a little bit on this. So I want to go into the background a little bit first. Who has done Angular before? Or maybe still? Okay, good. Right. So another decorator-heavy framework. So back in 2014, I went to the NG Europe conference. Was anyone else there? It was in Paris. Okay, so I took this photo. This is Mishko. And he was, this was at the transition point between Angular JS and Angular 2. And there was all sorts of innovative ideas going around at the time, right? What's Angular 2 going to look like? Is it going to be written in Dart? Is it going to be written in @script? Anyone heard of @script before? Okay, these are the hardcore, right? If you've heard about @script. So, history lesson. At this conference, Mishko basically announced Angular 2 is going to be written in this language called @script. And most people have never heard of this language because apart from at this conference, it wasn't really talked about very much. But @script, it's kind of hard to see from this slide, but he's made this diagram, and in the middle is ES5. And then encompassing that as a superset of ES5, you've got ES6, which has classes and modules, because this is back in the day when classes was new, right? ES6 modules was a new thing. And then encompassing ES6 as a superset is TypeScript, which adds, of course, types. And encompassing all of that was this language @script, which adding to all of those things, it adds annotations and introspection. And they did this, they actually built this language, right, in Google. And this was like the state of the art of what Angular 2 would look like. But this is like way before even alpha, I guess. This was just a preview. But you can already see it kind of looks familiar. You've got this directive, and it's got the @ sign. It's a decorator, right? They called it annotations at the time. Because of this @ symbol, this is where the name @script came from. And otherwise, it basically looks like TypeScript. So they were going to actually do this brand new language, and Angular 2 would be in this just totally new language that's just used for Angular, which is a pretty crazy idea. It never happened because in 2015, the TypeScript team announced that these annotation features from @script would actually be incorporated into the TypeScript language. And the Angular 2 would not be written in AtScript, not written in Dart, because that was another plan. It would be written in TypeScript, and that's where the whole thing started, right? And I'm glad they went that way. It's been for the benefit of us all, I think. So this decorators idea that was implemented at that time by the TypeScript team is what we call experimental decorators, because there was no standard about it. There was no like TC39 proposal. It was just like, I guess, Mishko's idea, and probably other people contributed to it as well. And this is what we use now. This is what we use in Angular. This is what we use in Nest. Experimental decorators. They're also known sometimes as legacy decorators. Usually you see that in the context of Babel, because Babel also implemented support for decorators, and it's almost exactly the same as TypeScript experimental decorators. They're also sometimes referred to as stage 2 decorators. Are you familiar with the stage process of TC39, how they standardize the new features, right? So it goes through stage 1, stage 2. By the time it gets to stage 3, you're like, okay, it's going to happen. These ones got to stage 2. They're not going to happen. They're not going to happen in the ECMAScript standard. There is a new standard for decorators, which is now at stage 3. So this one is extremely likely going to be in the ECMAScript standard. They're not supported by any JavaScript runtimes currently. Here's the screenshot from the Can I Use website, where it's like, it's all red, you just can't use them. But they are implemented in TypeScript version 5. So if you write a decorator in TypeScript 5 and you switch off the experimental decorator flag, it will still compile, and it's going to compile to these kind of decorators, stage 3 decorators, and they're incompatible with the ones that we all use. Not massively incompatible, but sufficient enough that you would probably have to like rewrite all the decorators. I'm not going to talk about these ones because we don't use them in Nest. It's just background, right? I think I've read somewhere in the Nest issues, like people saying, when are we gonna move over to these decorators? And I think I've seen Camille say, yeah, like at some point when they can do all the things that the TypeScript decorators can do, because the spec doesn't cover all the things that the TypeScript decorators can do. But so that's the background, a little bit of history. There's more to it. You can go deeper, but that's like, at least from my point of view, that's the journey it's taken as far as I've seen. Why decorators? Like, why do we even have decorators? Why did we need them? Why does the language need them? What even are decorators? What does it mean to decorate something? If you go back to my original opening slide, it's kind of a joke, right? So, at least in English, a decorator is someone who decorates. Usually they paint the room and they put the furniture up, right? So this is a decorator, a magical decorator. But what does it mean to decorate? So here's the typical example of this. And this is a software pattern, right? It's in the design patterns book that some of you might have read. It talks about all these kind of different object-oriented patterns, but to decorate something is like to add capabilities to some existing function or class without changing the structure of it. So a typical example is something like this log function. So right here, the greet function, we've got a very simple function. It takes a name and it says hello name. That's all it does. Up here we have a decorator function, which is called log, and that receives a function. And it just logs the fact that this function is about to be called, and then it calls the function, collects the result, and then it logs the fact that that function was called and that it's got a result, and then it returns it. When we wrap the greet function in this log decorator, it doesn't change the behavior of the log. The log still logs the name, right? But additional capabilities are added to it. So it's wrapped it and it's added extra stuff to it. I can show you an example of that. So Is this the right one? No, that's not the right one. Let's go to 0, 1. So, ooh, is that the right one? No, that's not the right one. I want 0, 0. Yeah. Computers. So this is literally the same code that I just showed you in the slide. What was that shortcut for getting my terminal up? Alt, Shift, Alt F12. Ha, nice. Okay, let's run it. That was fast. It's doing a lot of work, you know. So you can see that this is logged by the decorator function, and this is logged by the decorator function. So it's working. So we can already decorate functions without any special syntax. Like, why do we even need this special at thing? Can anyone take a guess? Why do we need a decorator syntax when we can already decorate things by just wrapping a function around it?
So that we are writing. So that we are writing this all the time.
Yeah, but once I've defined this log function, I just need to wrap any function I want to decorate. I just need to wrap it. At the point where I declare the function, I can just immediately wrap it.
But it looks shit.
It looks shit. Okay, valid. Valid. Yeah. Yeah.
We've created a new thing within.
Yeah, that's right. So it's not exactly declarative, right? So there's one step between defining the function and then decorating it. There's a step, right? So that's a great point. There's an even more fundamental point than all of these things, though, right? You can't do this to a class method. You just can't. Impossible. So a method on a class. I'll show you. I've got an example. So 01. So yeah, I mean, yeah. Let's take a look at this. Why is this not closing? Oh, there we go. So here we've got the exact same log function. No change. Here we've got a class, person. They can do a greet. Okay. I've given the game away here because I didn't change my code, but so we can decorate greet, but again, it's not declarative because we have a step where we define the class, we've got a step where we have to then instantiate the class, and then we've got a third step where we can finally decorate this function, person.greet. And then let's run it. Now we're on, oops, example 1. So let's run it. And we got like a huge error. We've got a huge error. It says cannot read properties of undefined this.name. So this is coming into problems of this in JavaScript. Yeah, I could use an arrow function, exactly. Or I could do it like in the style of old-fashioned React, for example, and like bind it like this to the person instance, and then I believe it will work. Let's see. Yeah, so then it works. So there's a number of issues with it. So this is a fundamental thing that the whole decorators solution addresses. Number one, you can actually apply it in a way that doesn't require multiple steps. It's done declaratively at the point where the actual class is defined. And number two, you don't have to deal with these weird problems that come about with the scoping of the this object. Okay, decorators in NestJS. So yeah, like you write Nest code, you're writing decorators all over the place. On top of your class, you're writing decorators in front of your methods, you're writing decorators in front of your parameters. Those are the three places you can do it, in front of properties as well. What are they doing? How do they work? It's kind of magical, you know? It doesn't, in the docs, it doesn't really go into what's happening. It just says, you just do this. So I thought it would be interesting to kind of implement like a controller and a get decorator and just have a look at how it could work behind the scenes. So let's take a look. Oh, wait a minute. No, I've skipped too far ahead. Forget the whole bit. Let's go back to the logging. I should have shown you this before. So this is an example of doing the logging, the greeting on the class method, but this time with a decorator. So we have the same thing, but now, yeah, exactly like your point, we can now declare this log behavior directly at the point where we declare the class method. And the decorator looks like this. So I don't know if not everyone has written a decorator from scratch, because it's just not something that you have to do that often. It's kind of like using proxies or something like this. It's just like, you normally don't have to do them. Library authors do, but in application code, it's not that common. So the decorator function will take the target, which will be the class, the key, which is like the method name or the property name, and then the descriptor, which is like, the descriptor of an object, where it's got the getter, the setter, the enumerable, these different properties of an object. And then you can do stuff with that, and then we're just basically, the logic's exactly the same. It's just much more ergonomic to use, and just for the completeness sake, I will run that also. This is number 2. And it worked. Good. So now I can go to the NestJS bit. Now that we've established that that's how basically decorators work, that's the problem that they're solving. So this should be, yeah, this is number 3. So here's my application code. And it should look kind of familiar, because it's, I've tried to make it look kind of like Nest code. We've got a controller, which is defining the like kind of base path. And then we've got some get methods, and one of which defines a further path with a parameter in it. And then we've got a bootstrap function. So before we look at what's like going on in the code there, let's just run it and see what happens. So it just says it's registering root cats is handled by catscontroller.findAll, registering root cats/ID handled by catscontroller find1. So it's kind of somehow hooked itself up to this controller. If a request would come in, it would kind of know which class to use and which method to route that incoming request to. So, I mean, there's nothing else to the implementation in this example than just doing a console log. But hopefully you can kind of use your imagination to see how actually you could implement a little framework with that's going to handle the request. So let's take a look at what those decorators are actually doing. So this was the app code. The library code is just up here, so it's not too much. Okay, let's just go through this. So first of all, we've got this constant object. It's a map called metadata. It's a map, the keys of which will be a function, actually a class, the controller class. And this map can then store against that class, it can store information about its path and information about any routes which it exposes, okay? So let's take a look at the controller decorator. It's just basically, 4 lines, 5 lines. It takes the path, which is /cats in this case, and it actually returns a decorator function. This pattern you see it used a lot, especially in Nest and other frameworks, libraries that use decorators. It's a decorator factory. So it's a function which will return a decorator. It allows you to configure it, just like the factory function in general, if you're familiar with that other design pattern. So this is the actual decorator is here, and this gets returned. It takes the class, which will be, in that case, cat's controller, and then it gets the this object from the map right here, and it just sets the path. That's all it does. And if we look then at the get decorator, this is a bit more complex, but not too much. So again, it's a decorator factory, so we can configure it with the path. or if we don't provide a path, it will just be empty string, as in the case of the find all method. And then here's the decorator function. It looks up into this map, looks for the controller, which is always passed in as the target. If it doesn't find the controller, we'll just create a new object with empty roots right now. And then we push the current roots, the current path, and the descriptor.value, that's actually pointing at the method that we've just decorated. That's what that means. And we just set that data into this map and return the descriptor, which is basically like no operation. It just doesn't change anything about the behavior. And then the bootstrap function takes that metadata object, which we've been slowly adding things to, and we'll now just loop over it. Each class which is stored in there, we've only got one in our case, but if you have lots of controllers decorated with this controller decorator, you will have a number of classes which will be looped over. Inside that class, we have whatever roots have been defined, and we just log it out. But we have, as you can see, we have the actual direct reference to the method. So, you know, we can call that method if we want to. At the moment, we're just logging the name. But you can kind of get the idea of how it actually gets used. And that's it. That's how Nest works. Simple. Yeah, thank you. Obviously, there's a bit more to it than that. But fundamentally, when you're using decorators in Nest, this is all that they're doing. I'll prove it to you. I have the Nest repo right here. I just pulled from the master branch last night, so it's pretty up to date. If we look at, you know, they've got a lot of different decorators we can look at in Nest. So, I don't know, root params decorator. They've got some abstractions and stuff, but you can kind of see that if you, I don't know, where's the get decorator? Get. Oh, maybe it's not in that file. Let me see if I can find it. Get. Let's turn it on case sensitivity and that. Here we go. Here we go. Here it is. So get decorator is, well, it's abstracted out into this create mapping decorator, which returns request mapping. Oh man, enterprisey. Look what it's doing. It's just setting metadata on an object. This is all it does. Now, they do it a bit more fancy because they use this method of defining metadata, which is this reflect.define metadata. Has anyone ever seen this reflect metadata thing before? It's also, yeah, a few have seen it. It's kind of it's a low-level thing, and most of the time you don't have to deal with it. It's usually used by libraries. Conceptually, it's not really doing anything different than what I showed you with this map. It's like, you can give it a class or other objects, and you can define keys and values on it. And that's all it does. It does it in a kind of a nicer way, but conceptually it's the same. And if you would look at I think pretty much any Nest decorator, and you kind of drill down through the layers of abstraction, and you get to like, what is this decorator actually doing? And you will find, and we can probably see some more examples, it's literally, they're just setting some metadata on that class or on that method, which then, when it comes to bootstrap your app, they're able to look up that metadata and say, oh, what method should we use? What should we call now? Or, you know, what part of the request object should we return now? Because the metadata kind of points to the property name that we need to return when we do the like at body decorator or whatever. It's just setting metadata. So the conclusion is it's all about one thing, and that is metadata. My skills in making presentations are improving. This is higher than my usual standard, I've got to tell you. All right, but wait, what the hell is this reflect metadata anyway? So actually it comes from this package, reflect metadata. Oh God, where's my browser gone? That's not the browser. There. This is a polyfill which it polyfills a standard which will never exist. A bit like the experimental decorators, it kind of one of those things that didn't really make it to stage 3. And it just exists because of TypeScript, basically. It's maintained by this guy, R. Buckton. He actually works at Microsoft. And it's developed and maintained in coordination with the TypeScript team. So it's not like just some random guy, R. Buckton. Why is all of this modern infrastructure depending on this one guy? No, he works at Microsoft. It's okay. Yeah, and it doesn't really do much, this library, but it exposes this reflect metadata, define metadata, and get metadata. It's like, if you look at a map, you've got a get and you've got a set. It's like doing the same thing. And it even says in the README, like, oh yeah, you could implement it in this way, and you don't even need a new library. But as someone said before, it looks shit, so we don't do that, and we make a library for it. That's reflect metadata. Go away, Windows. You're right, this is called encapsulation, yeah. This is the fundamental principle of our craft. You hide the shit. That's right. Okay, so you basically know everything you need to know about decorators now, I think. I mean, that's not strictly true. You can do other things in decorators. Like I showed you an example with logging. You can write a decorator which will like time how long a function takes and then send the data off to some like metrics service or whatever. You can basically do anything around that function that you're wrapping. So the scope of decorators as a feature is much bigger than what I'm presenting. But in terms of like the NestJS meetup, it's set in metadata. That's all it's doing. All right, so I told you, I have this open source e-commerce platform, and we're based on Nest, and we make a lot of use of decorators. We have our own custom decorators, and that's how I went on this journey of like having to figure out what decorators really are doing. So an example of how we use it, getting back to the topic of authorization. That's right, authorization, permissions. So we have our own, of course, we rolled our own like auth system. We're pluggable, so you could plug it into Ori, maybe that's the thing that we could explore. But we have a permission system and we have a decorator, so we use GraphQL. So if you've used the Nest GraphQL integration, you've got like resolver decorator, you've got a decorator for query resolvers, like what you see here. So, and additionally, in a vendor application, you can specify who is allowed to access that query or mutation. And we have this allow decorator. And I can show you the code to that. You probably won't be surprised what you're going to see by now. So, allow decorator. So it's very simple. It does one thing. Set metadata. That's all it does. This set metadata actually is a utility exposed by NestJS. So if I click through to that, you'll see this is like inside Nest, and it says it's a decorator that assigns metadata to the class or function. So useful, you can use these, Nest kind of exposes its infrastructure for creating decorators. So once we've assigned this metadata to that particular resolver, then how do we use that? So if I go over to our auth guard, we have a little line here where we looking at what are the permissions required for this particular resolver function, and we say get that key, like get the metadata associated with that key that we set in the decorator. And this is actually an interesting thing, is that also part of this infrastructure that Nest provides is this reflector service, which is like their native way of fetching those metadata values that have been decorated earlier at the kind of build time or authoring time. So that's like a little bit of a peek into how you can actually use those. Once you've set the metadata, of course, you need to be able to read it, and you would use the reflector. Okay, we do a little bit more complex stuff than that with decorators. So we have a plugin system because we target the kind of more complex e-commerce applications. Usually you've got lots of custom logic and modules that you want to support. You might want to add support for like reviews or a wish list system or a customer loyalty scheme or whatever. And we encourage people to encapsulate it into a plugin. And we provide this decorator to do that. And it's actually built on top of the NestJS module system. No, don't want to do that. And I'll just show you a little peek of this. I'm not going to explain it all, but you can just see kind of what can be done. So let's see if I can find that file. I guess it's here. Okay, yeah. So this is the decorator. You can see, again, it's a decorator factory. So we're passing in all that metadata, all that config stuff. And then we do kind of set some metadata, but then an interesting thing you can do is right at the bottom, you'll see the last thing that we do in this decorator is we actually wrap the NestJS module decorator, because you can actually, decorators are just functions. You can just call them. You don't have to use them with this @ sign. If you just call the function, you pass the right thing, it just works the same as it would, as if it was, on your class with an @ sign. So this is a nice way of composing decorators. You can have one decorator that like wraps another, does some custom stuff before. It's almost like decorating a decorator, right? Maybe it's getting a bit meta now, but you can do stuff like that if you need to. I should put that caveat. If you really need to. Otherwise, don't do stuff like that. That's it. Thanks.